In the universe, almost everything obeys strict laws. Even chaos is just a veneer. The cosmic microwave background remains the most stable known phenomenon. It has barely changed since the Big Bang. That's why the data obtained in mid-January at Orpheus Station was a real violation of reality. The station was in the Atacama Desert, amidst the rocks and dried roots of cacti, where the nights were so quiet that you could hear your own pulse. On nights like this, the cleanest signals from deep space were recorded. That's always been the case, until the moment when the background spectrogram suddenly showed a narrow, dark streak. It lasted only a few milliseconds, as if someone had cut a microscopic fragment from the continuous noise of the universe. At first, the station was supposed to have a glitch. Cosmic rays, static discharge, microscopic sensor error. There was a lot of choice of explanations. But 20 minutes later, a second such failure appeared. 20 minutes later, the third. The interval was perfectly accurate. 20 minutes. It's not a noise anymore. An in-depth analysis revealed an even stranger circumstance. Failures appeared at frequencies that were not supposed to fail. They're so stable that entire models of the early universe's evolution are tied to them. But each failure looked like a neat, mathematically perfect lack of signal. It's like someone was turning off a source of fundamental radiation for a moment. When the data were compared with readings from other observatories, it became clear that the phenomenon was not local. It's been recorded in Australia, the Canary Islands, and even orbiting telescopes have seen the same hole. She wasn't part of the instrument. She was part of the universe. A dot that should not have existed was noticed on the 20th iteration. When the failures overlapped, their edges formed a barely noticeable asymmetry. There was a possibility that it was noise. But the more often new failures occurred, the more clearly the structure emerged. Extremely simple, devoid of any obvious patterns, but still a structure. It consisted of the densities and tenuousnesses of the background, forming a faint semblance of a spiral. The spiral could not be explained. It did not match known supernova remnants or ultra-distant galaxies. It was as if it was in the very fabric of space, without having a physical location. It's as if space itself was trying to show what was happening to it. After a week, the sinkholes began to lengthen. They now lasted not 3, but 6 milliseconds. Then it's 9. It was a growth too regular to be random. Physicists have suggested the temporal nature of the phenomenon, as if the universe was missing its own noise for a split second. But along with the length of the dips, the background amplitudes also changed. In rare moments before the next dip, the noise temperature level rose slightly, almost imperceptibly, but fixable. It's like space got hotter for a moment and then lost some of its energy. And then came the most alarming calculation. If the progression continues, in a few weeks the duration of the failure will reach second values. And a second of silence in the microwave background would mean a huge loss of energy at the level of the most fundamental structure of the universe. It's not just a violation of the laws of physics. It's turning them off for a moment. Stations continued to record dips. Now the interval has shortened. Instead of 20 minutes, it's 16. It was as if an unknown process was accelerating. Scientists have tried to build a model, but all attempts have failed. There was no theory that would allow for such voids in the cosmic background. At the 48th hour, when the length of the sinkhole had already reached 40 milliseconds, stations around the world noticed another strangeness. After each failure, the background was restored, but its structure was slightly shifted, as if in the video footage someone had changed the pixel for a fraction of a shade. And the further you go, the stronger the shift was. It was too slow to notice with the eyes, but fast enough for the instruments to record. The cosmos was a little different after each failure. When the failure first exceeded 100 milliseconds, the data was sent to closed research teams. The working hypothesis was incredible, but the only possible one. There was a phenomenon akin to a local update of the properties of a vacuum. In theory, this is only possible in the early universe, in the first fractions of a second after the Big Bang. But not now. Not after 13.8 billion years. Observations continued. The failures were lengthening. The intervals were shrinking. The spiral was getting clearer. It no longer looked like a noise. It was a structure forming of itself. When the failure reached a quarter of a second, stations around the world recorded a single jump in background temperature. It was tiny, but in sync. An event of this magnitude could have had only one explanation. The changes were not local but universal. It's as if the entire universe has undergone a microscopic phase change in synchrony. The rhythm has broken down in recent hours. The failures began to happen not on schedule, but with mild tremors. Then it's all messy. Then they disappeared, as if the phenomenon had run its course. The world relaxed for a moment, but it was after the anomaly disappeared that what many called the strangest observation in the history of cosmology occurred. The cosmic background is a tiny fraction of a percent flatter than before. It's unprecedentedly even. It has disappeared, an ancient fluctuation that was present in the images of the entire time of observations. It's like someone erased a tiny unevenness in the fabric of space, a bump that's been billions of years. No explanation has emerged. Official records claimed that this was a statistical error. But in the unofficial logs of Orpheus Station, a short note by the engineer who checked the data remained. He wrote, "There's no point here anymore. It's gone. And I'm sure it didn't disappear on its own.